Hello, good morning to all. Today we have to study about understanding of hydraulic symbols. In previous lecture, we have to study many more types of the hydraulic symbol and basic principle of hydraulic symbol. The introduction for that we have to already discuss in our previous lecture for an hydraulic symbol. We have to repeat it. That's introduction part in these videos. Hydraulic circuits are compressed cylinder and valve pumps and are the connected via hydraulic pipes and tube. That means that here there is a many more working component parts in a hydraulic circuit. There is a combined drawing and combined working system that's called a hydraulic circuits. The complexity of these components are difficult to represent fully because of there is a number of part is available there and number of parts at working in a different way, different process, different load condition, input output. So hydraulic symbols and circuit are used instead of hydraulic working components parts. It's easy and clear to represent of each hydraulic component. So it's necessary to you have to draw any hydraulic circuit with representation of hydraulic symbol. This is also introduction part for the hydraulic symbol. The symbol that represent hydraulic component typically display the following characteristics. Function. What is the function of the hydraulic symbol? That's represent the actuation and return actuation method means the working fluid are inlet, outlet, flow of working fluid, number of connection is there available, one, two or more than two connection in the components parts, switching position on off condition, general operation principle, which principal operation as their working condition for any hydraulic symbols or hydraulic component parts is maybe simply represented by the hydraulic symbols. Simplified representation of hydraulic flow path. It is easy to represent hydraulic flow path from the components inlet to outlet where the fluid flowing. It's a easy to understanding of hydraulic circuit is necessary to we have inputs hydraulic symbol. In the last lecture, we have to completed hydraulic motor, unidirectional motor and bidirectional motor. Then after the completed variable unidirectional motor and bidirectional motor. For a pneumatic side, we have to completed unidirectional air compressor and bidirectional air compressor and with variable uni and bidirectional pneumatic compressor. Then after the completed for hydraulic motor and pneumatic motor with unidirectional single speed and fixed speed. Then after the completed for pressure control valve, the pressure control valve available in the circuit so that it's necessary to have to attach the pressure control valve in this the system. The pressure control valve you have to study it pressure relief valve, sequence valve, pressure reducing valve, and unloading valve we have to completed in our previous lecture. Today we have to study about direction control valve. DCV. We have to certify name is that direction control valve. DCV. Here is the one directional control valve is mentioned as this square block mentioned as a direction control valve. There is a three blocks inside the diagram: block 1, block 2 and block 3. This may be represent a number of position. Simply we have to study or understanding about DCV. This position called as a 1, this position called as a 1, secondary position called as a 2, and third position called as a 3. The type of DCV is 4 by 3. 4 means there is a number of port available in the direction control valve. 3 means available position, position 1, position 2 and position 3. 3 position possible in this direction. Number of port we have to mention in here. These are port 1 P, port 2 T, port 3 A and port 4 B. This is the port, means you have to mention this port 1, port 2, port 3 and port 4. P means there is port is directly connected to a pump. This port mentioned is directly connected to a pump. And here T means tank. This port mentioned is directly connected to a tank. Here port A is mentioned is directly connected to another element, and port B also mentioned that that's also directly connected to another element, means next working components parts is there is connected with A and B. P connected to a hydraulic pump and T connected to a directly to return tank. This is the 4 port. That means the DCV types is 4 and position possible is we have to mention is position 1, position 2 and position 3. So the name of this DCV is 4 by 3. I have to repeat first that 4 it means number of port available in DCV, and 3 mention number of position of DCV. Port means P means hydraulic pump, T means tank return, A means connected to another element or component, and B means connected to another component and element. Here we have to show one spring is there and one spring is there, means that it works written with a spring. And here the symbol is the solenoid 1 and solenoid 2. It's represent the DCV is directly operated with solenoid valve 1 and solenoid valve 2, and the return condition is spring. It may be written with the spring first. This is the basic structure of DCV. We have to study in a types of DCV. This is the types of DCV. The first is 2 by 2. 2 means number of port is available in a 2. Here is a 1 port and here is a 2. This number of port available is 2. So it's clearly represent is a 2. And the divide by 2 means it's represent the position of valve. That's to represent means number of position possible. That means represent a number of position in a 2. To close port in the closed natural position and the flow during the actuation position. Here these positions are mentioned. The port is a clause. This position are mentioned. Port is a clause. If the running condition for DCV This position mentioned as a fluid flow from position 3 to 2. It's also a mention a direction of flow. Two positions are possible for this DCV. The next is a 3 by 2 valve. It is a 3 by 2 valve. The number of connection is 3. The connection 1, connection 2 and connection 3. Number of connection is 3. That you have to mention as a 3. And 2 position are possible. Means we have to represent 2 position are possible. Position 1 and position 2. 2 position are possible. In the first position, the flow take place to the cylinder. In the first position, the flow from to another position means it's passed from the pump to cylinder. Here we have to mention the flow from pump to the cylinder. The next position is in the second position, the flow takes out the cylinder to exhaust. Means the cylinder has compressed oil received at the position 1. Then after the flow is returned to 2 to 3 and is taken out at the tank return from the port 3. These mostly work based on a single acting cylinder. This 3 by 2 valve always used for a single acting cylinder. For the next DCV is 4 by 2 valve. There is a number of port is 4. Port 1, port 2, port 3 and port 4. There is a number of 4 port is available. There we have to mention is 4. And by 2, it's represent the possibility of position is 2. The possibility we have to see, the possibility is 1 and possibility is 2. It's clear that 4 by 2. 2 position and 4 port. For double acting cylinder is used for all port are open. The 4 port all are open. There is no any restriction, but we have to show that then there is a number of position available for this way: in, out, cross in and then cross out. Here the position is here. The oil is coming from the pump and out to a cylinder. And secondary condition is the oil is coming from the cylinder and enter into the tank. Here is a vice versa, and flow is come from the pump and goes to a cylinder another side, and for the another side's oil return to a tank. This is a 4 by 3 direction control valve. The next is a 4 by 3 direction control valve. 4 means mention position 1. 4 means number of port available 1, 2, 3 and 4. And 3 is mentioned number of position is available. Position 1, position 2 and position 3 is available for this. For all types of the 4 by 3 valve, the 2 open position and 1 closed natural position. For any 4 by 3 direction control valve, 2 position open and one close. This middle position is a close or any natural position. Two position means this position and this position are always open, and middle position is depend on working condition, close or any natural position. There is a possibility for middle position is a different for as a working condition, like as a open center position, closed center position, tandem center position, regenerative center position, and float center. Using in a 4 by 3 wall in a middle position, there is a possible condition: open center, closed center, tandem center, regenerative center, and float center. This is the different position for an 4 by 3 wall. The next is a 5 by 2 wall. There is a number of connection is 5. Is a 1, 2, 3, 4, and 5. Number of connection is 5. And second is that the position 4 is only 2. Position 1 and position 2. The possible connection position is 2. Two open position with two exhaust port. Here 2 is a open position and 2 is a exhaust port, and 1 is a complete closed condition for an 5 by 2 wall. Next, we have to show direction control valve actuation method. If you have to operating any type of the valve for an external sources, DCV cannot operate itself. Here you have to mention this is the operation condition mentioned is here. This position and this position, this is operating condition. Here the spring is mentioned, the DCV is written back with spring, and this position are mentioned as a solenoid. It means the input condition working by the solenoid. So it is necessary to working with any direction control valve by actuation method. The first method is general manual actuation. Means we have to give manually operated by the load on direction control valve. Here the next is a push button actuation. We have to push button and return with the spring. That's called as a push button actuation. We have to give external load by hand or foot. That's called as a push button actuation. The next is a lever actuation. Lever actuation means is that we have to give an any lever, we have to moving clockwise or anti-clockwise direction for a load condition and release condition. Here the next is a detent lever actuation. It may be variable, so we can adjust the load condition during the direction control valve in a manual operation of DCV. For a detent lever, it may be on a step condition, so it may easy to operate the lever in a manual operated DCV. The another is direction control valve actuation method, but this actuation method is mechanical actuation of DCV. We have to not operating by manual method or hand operated method. It may be operated on mechanical actuation of DCV. The first is Foot pedal actuation means we have to apply the load on DCV by foot. Secondary is a roller lever actuation. We have to give the another component part which give the force on roller, and actuation can active by the DCV. It may be change the its position from 1 to 2 to 2 3 or 2 to 1 or 3 to 2. It may be can change its position. The next is a idle return roller actuation. This roller is connected to another shaft with cam and it operated by the cam. This is idle roller actuation. Then after the next is a spring actuation. This work based on a spring. One time you give the force on manually and another side is written with a spring force. The next is a pneumatic actuation of DCV. It may operate by the pneumatic device. Direct pneumatic device are connected to a compressor, and compressor gives the compressed air and it's operate direct actuation method. This symbol is mentioned connected to a pneumatic system and it's create a force on DCV. That is called as a direct actuation method. Here the next is non-return valve, types of non-return valve. The first symbol is mentioned check valve. Allows to flow in a one direction and block flow over in the return direction. This check valve allows flow in one direction and blocks flow in another direction. Means that only and only flow can one direction. If the flow is back in a pipe, the valve is closed and not allowed to flow in a return or back side. This is the symbol for check valve. The symbol is mentioned that the one point is a input and another point is a output. We have to consider this point is a input and this point is a output. Means that flow can flow from this direction, but the return flow is not allowed, so that this circular ball can attach in this triangle and it stop the return flow. Means flow from this left side to right side, but it never flow from right side to left side. Means it block the return flow. The next is a spring loaded check valve. Here the next is a spring loaded check valve. In the first there is a operated by gravity or manual, and the here second is a operated by spring. If you have to consider for this flow, the flow direction from this is input point and output point. The flow from this side to this side, means left side to right side flow from past. And second condition is there, the flow can never from reverse. It may be blocked by this ball and spring force. Means the flow only pass in one direction, it cannot be pass in a return for this direction. The next is a shuttle or or wall. When any one of these points is given, the output is produced. There is a number of connection is 3. Here number of connection is 3. Connection 1, connection 2 and connection 3. Number of connection is 3. Only 2 connections are operated. The flow output is produced. The flow output is produced. If you have to consider the flow start from inlet condition, from this place the working fluid can enter into the shuttle valve and exit from this point. If this position are at a time is blocked, at this time this position are blocked. When the flow from this point and enter into the system and out from this point, only 2 ports are in working condition, the output is produced. That's called as a shuttle valve. If this circle is in center, the input from both side and output from this side, means valve R is in operating condition. The next is end valve. Only when the both input are given, output is produced. When the both input are given, then also output is created. Here we have to mention for input output condition and number of port. Here is a port 1, port 2 and port 3. These 3 port, if we have to give flow from this direction, the these port are closed. It may be not in a working condition. At this time the flow work goes out from this position. When we have to give the force from this side, the flow is working from this side. That's called as a end valve. Here the next is quick exhaust valve. For quick exhaust of air is causes rapid extension and retraction of cylinder. This position we have to mention in a 1, 2 and 3. But in this case the position is a closed condition where we have to require a quick exhaust from the working line. This dotted line are mentioned the working of excess pressure can remove from this line and return to the check valve, and it's balance the line pressure and give against protection on the higher pressure. Next is a flow control valve, FCV. The normal symbol for that is flow control valve, is to allow to control flow. If the maximum flow or excess flow occurs during the hydraulic circuit, it may be necessary to control the flow. Here this symbol is mentioned a flow control valve. This symbol is a normal symbol for flow control valve. That's mentioned is a variable restriction flow control valve. This point is a input and this point is a output, and this arrow drawing is mentioned a variable condition, means we have to vary the flow as per requirement condition. The next is a flow control valve with one-way adjustment. Flow control valve with one-way adjustment to allow the control flow in one direction and free flow in another condition. Here the flow can pass from this side, means this is a flow direction, and here is give a return free flow, means the excess oil in the system can return and enter into the continuous back line. These are another different types of the flow control valve. Here the flow control valve is a pressure compensate valve. It operates on pressure base. Then another is a temperature compensate valve. This is a free flow we have to already discuss in previous slide. This mention a flow condition input. This mention a flow condition output. Here the one arrow drawing is here. It's measure the pressure of the system line and control the pressure inside the oil. Here is the also a valve for temperature compensate. It's the control the temperature of the valve. Also the temperature compensate valve is measure the oil temperature as per the requirement. This figure and drawing we have two taken from this website machinedesign.com. If you have, okay, thank you.